Here's the continuation of section 10.2. So to kind of summarize what we have so far, the law of sines we use when we have one side and two angles given, be it two angles in the side included or two angles in the non-included side. You can also use the law of sines whenever you have two sides and the angle opposite, or two sides in the non-included angle. That's the special case where we get 0, 1, or 2 triangles possible. So that's the only time that that option is on the table for us. For the law of cosines, we're going to use it whenever we have two sides and the included angle, or side angle side, or all three sides given. Now, you might say, well, why don't I just use the law of sines? Because I really like the law of sines. Well, you can't. You don't have enough information to use the law of sines. So that's why the law of cosines comes to the rescue. Now, for these two cases, for the law of sines, the law of cosines, whenever you have side angle side, that's two sides and the angle between them, here's the steps you're going to want to follow. You're going to want to find the side opposite the given angle using the law of cosines. Then you're going to want to find the smallest angle of the two remaining using the law of sines. Then you're going to want to use that 180 degrees total to find the last angle. For side, 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 you want to find the largest angle first using the law of sines. Then you can find either one of the other two using the law of sines, and then 180 using use that to find the last angle. The reason for this is because if you happen to have an obtuse angle show up in one of these triangles, it's going to get messy if you try to do it a different way than what I have here. So I'm trying to help you guys avoid those rare but sometimes happen instances where there's an obtuse angle in there and it just messes things up. So, all right, I'll show you what I mean by this. So let's go on to example 3. So let's solve the triangle where A is 3, B is 3, C is 3. This is a side, side, side. I gave you 3 sides. So let's find the largest angle first. Now you may be saying, I don't have any of the angles. How do I know which one's the biggest? Well, you know which one's the biggest because the biggest angle is always opposite the longest side. So which of these sides is the longest? Well, these two. In fact, these two are the same, so these angles are going to be the same as well. So we can find either alpha or beta. Because A and B are the same and they're the longest sides, their angles are going to be the largest angles. So we can find either one of those first. So I'm just going to use this version of the law of cosines. So I don't know if you can tell, but I'm going to be finding alpha from this. So I'm plugging in for A, B, and C. B and C, the 2 is part of the formula. So I get 9, 9, 4. 2 times 3 times 2 is 12. Be very, very careful right here. When you go to simplify this, you can combine these two like terms. This 9 plus 4 is 13. Do not subtract those two. You cannot take 13 minus 12 and get 1 cosine alpha. That's because the order of operations. This 12 is multiplied by cosine alpha. I can't do this subtraction before that multiplication. It's very tempting right now to do that. So if this were something like 9 equals 13 minus 12x, you wouldn't subtract that and just get 1x, right? You would subtract 13 and then divide by negative 12. Same thing here. You got to subtract 13. That's where the negative 4 comes from. And then divide both sides by negative 12. So that negative divided by that negative is positive. So I have cosine alpha equals positive 4/12. If I want to find alpha, I have to take the inverse cosine of it. So the inverse cosine of 4/12 is about 70.53 degrees. So there's alpha. Now guess what? That's also beta. So we don't have to work that hard to find beta. Because A and B are the same, alpha and beta is going to be the same. So now to find gamma, we just use the fact that the three angles add up to be 180. So alpha plus beta plus gamma is 180. We know alpha and beta are the same angle, so add those up, subtract it from 180, and we get that gamma is 38.94 degrees. So right here is where most students mess up. They struggle with how to solve this. It's very much like an equation in that you have to subtract 13, divide by -12, but then you have that additional step of needing the inverse cosine because you're solving for alpha and there's a cosine function there. So you have to do the inverse to get to the alpha. All right, that was a side triangle. This one's going to be a side angle side. So that means two sides and the included angle. So we have A is 10, B is 3, gamma is 15. So here I've sketched out for you so you can see that it's two sides and the angle between them. So with this one, we're going to start off, we're going to use the law of cosines to find C, to find that side opposite the given angle. Because I would need to find C, that's why I'm using this version of the law of cosines. Okay, so I'm just going to plug in for A and B and gamma. And then this one's a little easier than the last example because it's just a straight computation. So no weird kind of solving business going on there. So 10 squared, 3 squared, 2 times 10 times 3. And then we're going to add 109 minus 60 times cosine 15, and I got about 7.14. You should pause the video, do that computation with me, make sure you can get that. Now, let's use the law of sines to find the smaller of the remaining angles. So we have gamma, the smaller of alpha and beta. So how do I know which one is smaller, alpha or beta? Well, beta is opposite B and alpha is opposite A. The shorter of the two sides is B. So that means beta is going to be my smaller angle. So I'm going to solve it for beta. So I'm going to use this version of the law of sines. So I'm going to plug in for gamma, the C value I just found. B is 3. Then we're going to cross multiply. Should be pretty familiar with how this is going to shake out. Divide both sides by 7.14 and take the inverse sine of that. I got about 6.24 degrees, a little teeny tiny baby angle. And then lastly, we know that the three angles add up to 180. So I'm just going to add up that beta and gamma and subtract that from 180 to get alpha's 158.76. Because this ends up being an obtuse angle, this would have been a lot more complicated if you had found alpha first. So that's why I'm kind of giving you these tips on, how to handle these to avoid those weird situations when they present themselves. Okie dokie. So last up here, find the area of the oblique triangle with sides 22, 45, and 31 inches. Now, with this one, because we're given three sides and none of the angles inside, we have those formulas, but they all require an angle, right? Remember all these area formulas in here? But we do have this last area formula in here with all this nonsense. That's what we're going to use here. So what you could do, if you wanted to use one of those other three that we've talked about, you could use the law of cosines and find one of those angles and then use, like the 1/2 AB sine gamma, things like that. Or we can use something called Heron's formula. Heron's formula uses just the side lengths, none of the angles. So this is what's called Heron's formula. It's S times S minus A times S minus B times S minus C, where S is called the semi-perimeter, as in half of the perimeter. You know, like a semicircle is half of a circle. This is half of the perimeter. So this just becomes a plug and chug. First up, we got to find S. So it's half of the three sides. So our sides up here, for example, 5 were 22, 45, and 31. Add them up, divide by 2, we get 49. And then we'll just do some quick plug and chug into Heron's formula. And you can type all this into the calculator exactly as it looks, or you can just type in this multiplication, get that answer, and then take the square root of that answer and get that 308.64. But I would encourage you to pause the video, grab a calculator, make sure you can do those computations, because I would really hate for you to, miss this because you struggled with the computations. So, all right, well, that finishes up section 10.2.